morning, everyone. Thank you, Mr. Powell, for a wonderful introduction. Uh, the topic given to me by Dr. Habbu is really vast. The landscape of mechanical recycling technologies for PET, and he told me that I have to cover everything in 10 minutes. So, but as usual, Dr. Habbu, I would request that I have that 3 minutes extra as per the rule. So, I won't take more time. So, can you please? So the content is basically I'm going to talk about the PET recycling, what is the recycling of PET, then the mechanical recycling process, some details about the mechanical recycling. Although mechanical recycling is a very much discussed topic, and I'm sure that everyone is really aware of this kind of the processes available. And then what are the different technologies available, what are their pros and cons, the benefits, and also I've tried to show some comparison between the mechanical recycling and chemical recycling process, and then summary. So PET recycling is basically a process of transforming post-consumer waste or the industrial waste into recyclates that with a quality which is equivalent to the virgin. Uh, Recently, FSSAI has issued the revised guidelines for PET recycling, and they have broadly covered the 4 processes which are allowed to produce the food grade food safe PET, RPET. So one is the mechanical recycling, that is super clean recycling process. The melt-in mechanical plus semi-chemical. The third one is paste-in. This is basically a chemical recycling process, including the glycolysis, glycolytic depolymerization. And the fourth one, you can say it's advanced recycling, where you go up to the monomer stage, RPT and RMEG. So this recycling process basically allows to again reproduce the PET or polymer suitable for the same application. And you can definitely imply these technologies, the mechanical recycling technologies, to achieve the overall performance which is equivalent to the virgin PET. So this is the overview of all kind of plastic recycling technologies available globally. Some of them are already commercialized, some of them are on the verge of commercialization. Some of these technologies are at the lab scale or the pilot scale. And this chart shows basically the effect of the technology on the CO2 reduction, the greenhouse gas reduction, as well as what is the yield that they produce. So you can see the mechanical recycling process has both the benefits, the highest reduction in the greenhouse gas generation. Also the yield is very high. There are other chemical recycling processes, pyrolysis, which is now commercialized. The gasification is also proven to some extent, but you can see the overall the energy requirement is extremely high as compared to the mechanical recycling. Plus there are still issues about the total yield. So it is it will take some time to prove their efficacy in terms of the commercial viability of these technologies. This chart basically shows the different kind of mechanical recycling processes available, and these are all commercial processes. This particular chart is also included in the recent BIS draft, which is under wide circulation for food grade RPET. So you can see the input material for the mechanical recycling process is the hot washed flakes. And the center box is basically the different, you can say, the stages during the mechanical recycling. So it starts with the drying of flakes, whether it's a hot air drying or it's a vacuum drying. Then there is an extrusion process with or without vacuum, depending on the drying available. Then there is a chemical treatment, which is also in practice, chemical treatment drying. There is another process which directly goes for the liquid state polycondensation. Then if you have a conventional process, then from extrusion you have to pelletize, then you have to solid state polymerize to increase the IV and to retain the polymer properties, and finally it goes for the food grade RPET. So all these processes, there are different permutation combinations, and each and every process is well proven in terms of their decontamination efficiency. They are fully suitable for 100% RPET for food contact applications, and these processes have the food contact clearances from US FDA, EFSA, or even FSSAI. So this is the most important slide in my view, because how do you assess the performance of mechanical recycling process? What are the influencing factors? First and foremost is the feedstock quality. The mechanical recycling process, one drawback as I can see technically, is the once you have issues with the feedstock, then there is a little that can be done during the mechanical recycling process, because what you put in the extruder, the extruder or SSP have a certain the process window to decontaminate and to improve the performance. So the feedstock quality is extremely important. There are specific guidelines given by each technology that you have to have this quality of flakes. Then only they will guarantee the proper decontamination and the food grade quality. The process variables, the extruders which are available, the technologies available, they use different kind of extruders, single screw, twin screw, or even the multi screw. That also has a pronounced impact on the overall performance of your product and also the overall operating cost. So it is very important factor. The degassing, which is very essential for the decontamination of flakes or the molten polymer. The process history, that is temperature and residence time, that actually determines the overall the degradation behavior of your polymer during the processing, because some of the reactions are reversible, some of the reactions are irreversible. So it is very critical to set the proper processing parameters to achieve the good quality of RPET. Oxygen and water, these are, you can say, the poison for any kind of the polyester processing, because oxygen and water, they generate a lot of degradation, they induce very quick degradation and in turn the degradation byproducts. Chemistry variations, like what kind of feedstock you are in PET recycling, in wash line, basically you have a mix of all kind of bottles, water, soft drink, hot fill, certain trays. So, and these all applications demand the different quality of virgin PET. I mean, the recipe is little bit different in all these applications. So that also has the impact on the product quality. You add certain additives or performance enhancers to improve the performance of virgin PET, or during the recycling also certain additives are being added. So they also affect the overall mechanical recycling process. So these all factors are very critical in terms of achieving the good quality of RPET, which is really decontaminated to that extent that these you can achieve the good kind of the overall polymer purity. The 5 technologies, there are more technologies, but in general these 5 technologies are dominating globally in the mechanical recycling sector. I have not named them, but I am sure that many of you will be able to identify which technology. So this is the published data, and to best of my knowledge and based on the scientific evidence available. So the significance, some of these technologies, like some of have the vacuum assisted drying plus extrusion plus SSP. The decontamination efficiency, you can see fairly more than 95% each and every technology is guaranteeing, and in practice also it has been achieved. Specific energy consumption, if you can see, there are a lot of variations, because as I said, it is all depending on your the configuration of your extruder, SSP, or even the drying. So overall energy efficiency, you can say in some of the technologies they are extremely energy, you can achieve a lot of energy savings. Advantages, disadvantages, I have purposely not mentioned. The advantages are the first technology, you can say it has a shorter melt residence time, because the drying is done. So it is not only the drying, but the decontamination is also achieved when you vacuum dry the flakes. So you don't require that extruder with the degassing or the vacuum. So you have a very short residence time in the melt. That again helps in improving the color. The second technology, it is basically the extrusion is having a very fine vacuum. So you can achieve, technically or directionally, you can achieve a better decontamination. The another technology which is very popular in Europe, it has a different kind of heating, the microwave heating for the quick heating and the drying of the flakes. There is no SSP, so you can see the energy consumption is on lower side. The one technology which gave you the final product, the high IV product, only in the melt stage. So avoiding the need for the solid state polymerization. So you have a little bit advantage in terms of capex and the space requirement. One very innovative technology, although it is commercialized but not popular, which allows you directly to process the decontaminated flakes. You can combine this with the either with the injection molding or the extrusion for film and sheet manufacturing. So, and all these technologies, they have proven decontamination data. EFSA, you can go to the EFSA website and you can find out the actual data submitted for the food contact approval, or the US FDA website, you can find out all the data. They're all proven for the decontamination of the incoming flakes. Nowadays a lot of discussion is happening, and there are claims that the chemical recycling is better or the mechanical recycling is better. So I just for the benefit of just sharing this knowledge with the audience, that what are the key differences between the mechanical recycling and the chemical recycling. So chemical recycling, this includes everything. I mean the depolymerization, glycolytic depolymerization, or the hydrolytic depolymerization. So all kind of processes. These are the the broadly advantages or the disadvantages. So mechanical recycling, there are no technical challenges. It is established for years. The plants are running for last 15 years. I have personally visited those plants and running with full efficiency. Infrastructure requirement for mechanical recycling is obviously on the lower side. Commercialization potential, mechanical recycling, it's already commercialized, well established. Uh, the chemical recycling, you can say maybe a couple of years back, many processes were on the verge of commercialization, but now there are technologies which are commercially proven, and you can easily scale up those technologies. So, but certain processes are still proven on the pilot scale. Although they are very, very promising, because they can absorb wide variety of in-feed flakes or the feedstock. The purity can be maintained at very high level. So, but they are yet to be proven on the large scale. So, the commercialization potential is medium or high. Feedstock quality requirement, as I said, the chemical recycling gives you a very broad range of feedstock that can be accepted for the chemical recycling, because that process allows the inbuilt purification of the polymer melt. The quality of output, chemical recycling usually offers you a very high quality RPET in terms of the overall performance. Infinite recycling, there are doubts that the mechanical, and which is true also, because the mechanical recycling is a very harsh process. A lot of shear getting generated during the mechanical recycling in the extrusion process. So directionally the performance of your polymer usually deteriorates after each cycle. But chemical recycling, yes, you can go for the infinite recycling, because you can go up to the monomer stage. So the capex requirement, the chemical recycling is having, it's an enormous capex requirement as of now. Broadly speaking, the capex requirement can be as high as 2 to 3 times as compared to the mechanical recycling. So this is one of the major bottleneck. So in summary, mechanical recycling has a proven decontamination performance. We all are using, the products which are packed in the recycled PET. Lower capex and operating cost, easy to operate. Each technology has its own advantage, disadvantages, depending on the feedstock quality and the operating expenses. This point, for going to select any technology, this point is very, very critical, because usually my personal experience is, selection of technology is done based on, very few parameters, that what are the number of installations, what is your operating cost, what is your color of the product, and so on, the brand owner acceptance. But in fact, you have to really deep dive into the technology selection, because the polymer reaction engineering, which is very critical, and as I mentioned earlier, when you process the recycled PET, it really undergo a lot of degradation, and some of the reactions, I mean, how much that can be repaired, it is very essential in the identification and selection of recycling technology. The LCA studies are very, very important, because each technology has a different kind of the performance measure. So that also, there are maybe, you can say, the 10 to 12 critical parameters that you have to identify, you have to study, and then you should decide the adopting a particular technology. So it is very, very essential. The one of the bottleneck of mechanical recycling is, you cannot build a large scale mechanical recycling plants. there are limitations, whereas in chemical recycling, you know, you can easily put up the 100 kTA line there, which are also already built in Europe and US. So this is one of the bottleneck. You have to develop the novel technologies which can adopt the wide variety of feedstock, and you know, you can still scale up to a large extent. And as we all know that mechanical recycling is very well proven. There are no safety issues, health hazard issues or contamination issues in the product which is being packed in RPET. Yeah. So thank you.